Okay, so remember, you guys do have a test on tomorrow, and the test it will be all multiple choice questions, 20 questions, all multiple choice, and you guys are going to have to take the test in All in Learning. Let me show you guys how to access the test right now. Let me get ready to share my screen. So whenever you log into your computer tomorrow, in order to take the test, obviously you know you want to go through ClassLink first. So just type in your username and password, and then click sign in. Now, once you are in ClassLink, guys, you want to click on this button right here that says All in Learning. So we're going to take the test within the All in Learning platform. So you're going to click that. Okay. And of course, it should take you to the home page where you basically have to follow the instructions to get to the test. It's going to be 20 questions, all multiple choice. Now I'm going to say this: sometimes when you click on this All in Learning button, it doesn't always directly take you to the home page. Sometimes this page right here will come up. Let me show you guys what it looks like. Sometimes a page will come up that looks like this when you click on All in Learning, where it basically asks you to enter an email or a password. Guys, if this page comes up here, what you want to do, you want to scroll down here to the bottom of the page, and then you want to click on this button right here that says Sign In with ClassLink. Once you click that and sign in with ClassLink, then it will take you to the All in Learning home page. Okay, so don't worry about entering a username or email or a password. Again, just scroll down to the bottom if this comes up, and just click Sign In with ClassLink. And then from there, you should be able to follow the instructions to the test. Okay. So again, the test tomorrow will be an All in Learning. It will be 20 questions, all multiple choice. I'm giving a test because it's the end of the marking period, but technically we're not yet done with the unit. So even after we do this test, which is just going to cover the topics that we talked about so far, we still have a lot we have to cover in the unit. And so there's going to be an overall unit assessment when we get done with the unit in the coming weeks. All right. So now I want to spend the remainder of the class time going over a few important things you guys need to know for the exam. And that is, first thing first, I want to go over a few kinematic word problems with you all, because you guys will see you will see a couple of word problems on the test on tomorrow. And so I want you guys to understand how to do those problems if you see them or when you see them. So if I were you, right now I will pull out a sheet of paper and something to write with, because as we go over these examples, whenever you see whenever you see problems similar to the problems we're about to work out, you will know how to do them on the test. Okay. So in just a moment, I'm going to share my screen to show you guys what we're about to work out. So please be pulling out a sheet of paper and something to write with. Now, if you guys remember, a few weeks ago, I gave you guys this formula chart here. And guys, it turns out this is the exact same formula chart that will be given to you on the AP exam. We're going to work out two problems today that deal with using these first two formulas right here. I'm going to show you guys how to use the formulas. And then please be sure you're writing along with me, because when you see problems on the test, and these problems will look very similar. And these problems will look very similar to these two problems right here that we're about to work out. that please be sure you're writing along with me so that whenever you see these two problems, this problem right here, and also this problem right here, so whenever you see them on the test, you will know how to do them. Please be writing along with me. In fact, these problems are going to be they're going to appear almost verbatim to what you see here. The only difference is I'm going to change the numbers, but I just want to be sure everybody understands how to use the equations in order to do these calculations. Okay. So as I said, the first two equations right here is what we're going to use to work out two of the kinematic problems that you can see on your exam on tomorrow. Remember, off to the side, it tells you what each of these symbols mean. Remember, I said this last time. If you see the symbol X here, X represents position. So here, X means position. Vx represents basically your final velocity at that position. Okay, so let me write these equations. Let me write these first two equations down first, and then we're just going to work out a few examples together so that everything would make sense. So this first equation, I'm going to write this at the top. First equation basically says that an object's final velocity in the x direction is equal to an object's initial velocity in the x direction plus its acceleration in the x direction, all of that multiplied by time. Okay, so that's the first equation you guys need to know. By the way, guys, anytime you see this little symbol here that kind of looks like a zero, that is used to represent initial conditions. So in other words, this means your initial velocity. So this is what we use to represent initial velocity. Think about it like this. That means a zero, which represents your velocity at time zero, which is your initial condition, your initial velocity. So that's what that means whenever you guys see this symbol here. It looks like a little zero. We use that to represent initial conditions on the formula chart. So the second equation says that an object's final position, remember because x stands for position, is equal to an object's initial position. Anytime you see that little zero there, that represents your initial conditions, plus the object's initial velocity in the x direction plus, times time plus 1/2 times acceleration in the x direction multiplied by time squared. Okay, so utilizing these two equations, you'll be able to work out any problem that I give you on the test. Okay. Yep, I'm going to say that again. So this means, okay, an object's final position is equal to its initial position plus its initial velocity times time plus 1/2 times its acceleration times time squared. And again, we're assuming we're dealing in one dimension. We're dealing with the x, anything moving along the x direction. It'll make more sense. Everything will make more sense whenever I work these problems out. So look at this first problem right here. It says, an airplane initially traveling at 15 meters per second. Yes, the class is recorded. An airplane initially travels at 15 meters per second when passing the acceleration line. The airplane then accelerates at 6 meters per second squared until it reaches its takeoff velocity of 50 meters per second. What is the displacement of the airplane during its acceleration? Okay, so guys, what we're finding here, when it says, when we're finding the displacement of the airplane, in other words, we're finding, what is its final position, after it is accelerated for this particular time period. In other words, we're finding out how far the airplane has traveled. So guys, in order to solve for the displacement, or in other words, to solve for its final position, we're going to need to use both of these equations. So I'm going to tell you guys right now, the first thing we want to do, we want to solve for the time period the airplane is accelerating. Once we use this first equation here to solve for time, we're then going to take that number and then we're going to plug it in to time here in this bottom equation, and then that'll allow us to solve for its final position, which will basically indicate the displacement of the airplane. Okay, so let me just write down the first thing we have to do. First thing we have to do is to solve for time. Okay. So in order to solve for time, we're going to use this first equation to do that. So let me write down my first equation, that the object's final velocity in the x direction is basically equal to the object's initial velocity in the x direction. And again, this symbol here always represents our initial conditions, basically what the velocity is at time 0, plus the object's acceleration in the x direction. And again, we're assuming the airplane is moving along the x plane. Okay. Now that we have our equation down, guys, let us just plug in everything that we're given. So as the airplane initially travels at 15 meters per second, so that is obviously our initial velocity. So I'm going to plug in 15 for our initial velocity. Okay. It then says the airplane then accelerates at 6 meters per second squared. So that's our acceleration. So our acceleration in the x direction is 6 meters per second squared. Okay. Okay. And remember, we're solving this equation for t. Okay. What is our airplane's final velocity? Well, what does it say? It says after it accelerates, it reaches its takeoff velocity of 50 meters per second. So its final velocity after it has accelerated is just 50 meters per second. So I'm going to plug that in for its final velocity. Okay. Now, guys, how do I solve this equation for t? Now, tell me, I want to get t by itself. So someone tell me, the first thing, what do I need to do? I need to get rid of this 15. How do I get rid of that 15 to the other side? Can someone tell me?
Let's subtract 15 from both sides.
Exactly. You're going to subtract 15. That goes away. Whatever you do to one side, you have to do to the other. So 50 minus 15 is equivalent to 35. So this means 35 is equal to 6t. Now, how do I get t by itself, guys? How do I solve this equation for time?
Can you say that again?
How do I solve this equation for time? 35 is equal to 6t. What's the opposite of multiplication?
Or you divide 6.
Yeah. You divide by 6. That goes away. Whatever you do to one side, I have to do to the other. So guys, if you do 35 divided by 6, if you put that in your calculator, you're going to get 5.83 seconds. Okay. Is everybody following me so far? All I did, I just used this equation to solve for the airplane's time interval that it accelerated over this period. Okay. Now that I've solved for time, so the airplane accelerated over 5.83 seconds. Okay, before it took off. Now the question is, I want to know what was the displacement of the airplane during this time. In other words, from this point to this point, what was its final position? Well, guys, since I know the time period of acceleration, what I would do, I would just take this time here and I would plug that in to t for the second equation here, and that'll allow me to solve for its position, which is equivalent to the object's displacement, how far it's traveled during that time. So now I'm ready to use the second equation. So I'm going to come down to the bottom here, and then I'm going to write this out. So this equation, remember this equation says an object's, basically its final position is equal to its initial position, where this little symbol right here always represents initial conditions. So in other words, it's our position at time 0, which is our initial condition. That's okay, plus our initial velocity in the x direction multiplied by t. Guys, the formula chart is in Schoology. I posted in one of the folders in Schoology. I'm going to also post it again in the folder for today as well. Plus 1/2 times the acceleration in the x direction multiplied by time squared. Okay. So now, guys, let us plug everything in to solve for our final position. Okay. By the way, guys, in the problem, if you're not given an initial position, then just assume the plane starts from the origin. It starts from an initial position of 0. Okay, if you're not given an initial position, just assume the initial position is 0. Okay. So what about the initial velocity in the x direction? Again, this symbol here, this little 0 symbol represents your initial conditions. So our initial velocity in the x direction, remember we were told in the problem, so if I go up, remember we're told the initial velocity of the airplane is 15 meters per second. So the initial velocity is 15 meters per second. Okay. We just saw for the time interval of acceleration, we just saw for that time interval of acceleration was literally 5.83 seconds. So let me make this bigger. So this multiplied by 5.83. Okay, so 15 times 5.83. Okay, all of this plus, remember 1/2 is the same thing as 0.5 times the acceleration of the airplane. What was the acceleration of the airplane? Well, we were told that above the airplane's acceleration was 6 meters per second squared. So the 6 meters per second squared along the x direction, okay, multiplied by the time. Remember, the time here gets squared. Remember, we saw for the time, this time is 5.83 seconds. So I'm going to put 5.83, and I'm going to square that. Time must get squared. And I'm going to put all that in parentheses. Okay. So now that we plugged everything into our equation, now we're just ready to just solve this out. I'll just go ahead and calculate this. So 15 times 5.83 . So if I put that in my calculator, 15 times 5.83 is equal to 87.45. Okay. Now I want to put this in my calculator right here. 0.5 times 6 times time squared. All right, so whatever my time is, so 5.83 gets squared. Let me do that first in my calculator. So I'm going to do 5.83 squared first in my calculator. So put 5.83 squared. Then whatever that is, I'm going to multiply that times 6. Then I'm going to multiply that times 0.5. And that gives me 101.97. Okay. So I'm going to add these two values up, 87.45 plus 101 plus 0.97. Okay. That will give me 189.42 meters for the final position of my airplane just before it takes off. So the final position of the airplane after accelerated. So in other words, 189 meters represents the acceleration of the airplane. I'm sorry, 189 meters represents the displacement of the airplane. the displacement of the airplane after it accelerated over some time interval. Any questions on that first problem? Any questions? Hopefully that makes sense. Personally, if you ask me, I think the College Board, whenever they make these equations and they added all these extra subscripts, I think they make these equations more complicated than they had to. Because normally, in some textbooks, I don't see these equations this complicated looking. But the College Board, they are the people who make the AP exam, so I'm going to use the formula chart that they give. But hopefully, after my explanation, hopefully you guys were able to understand what each of these terms mean. Okay. And of course, even though these equations right here deal with the x direction, the same thing also applies for the vertical direction as well. So let's say you throw a ball and you want to find the object's final velocity, after the ball has decelerated upward. So in this case right here, instead of dealing with the x direction, in that case you would be dealing with the y direction. But the same equation applies for the y direction as well as the x direction. You can have an object moving horizontally, or you can have an object moving vertically. The same type of equation applies. So just something to keep in mind. Okay, let us do the second one. The second and final word problem we're going to do today. And this problem here is actually easier than the one we just did. In fact, we're going to have to use only one equation for this one. So for this problem right here, it says a boat initially moving at 5.5 meters per second accelerates at 2.5 meters per second squared for 15 seconds. What is the velocity of the boat after 15 seconds? Jade, I put all of my class recordings on my YouTube page. They're always on YouTube. So all the videos that I've recorded up to this point are already on YouTube. And if you want, at the end of class, I can send you a link to my YouTube page. Not a problem. So, this problem right here, a boat is initially moving at 5.5 meters per second and accelerates at 2.5 meters per second squared for 15 seconds. What is the velocity of the boat after 15 seconds? So here we're going to have to use this first equation right here because we're looking for the final velocity of the boat. So basically, so I'm going to take this first equation right here and I'm going to write this down. So the final velocity of the boat is equal to the initial velocity of the boat in the x direction, where it's understood that this symbol right here represents our initial conditions. We always use that to represent initial conditions, plus the acceleration in the x direction times time. Okay. So let's go ahead and fill everything in. We're told the initial velocity of the boat was 5.5 meters per second. So that's the initial velocity of the boat. We're told the rate of acceleration was 2.5 meters per second squared. Okay. And we're told the time interval acceleration was 15 seconds. So 2.5 times 15. So I'm going to put all of that in parentheses. So 2.5 times 15. So from there, just, now we plugged everything in, it's just doing the math. 2.5 times 15 is equivalent to 37.5. So this is 5.5 plus 37.5. Now, all we have to do is just add those two. 5.5 plus 37.5 gives me a final velocity in the x direction of 43 meters per second. So the speed of the boat, or in other words, the velocity of the boat, after it is accelerated over 15 seconds, is this value right here. So this is how fast the boat is moving after it is accelerated over a period of 15 seconds, and the rate of acceleration was 2.5 meters per second squared. Any questions? Y'all got that written down? Oops. All right, is everybody good?
Can you go back down?
Yes, I can.
Thank you. I got it.
All right, y'all good now? Okay, sounds like everybody's good. All right, so again, if you guys see questions like that on the test tomorrow, you guys should be able to know how to do the computations for those questions when you see them. Now, for the remainder of the class period, I just want to go over a few important things that you guys need to know. So, on the test, basically what I would do if I were you, I would log into Schoology and go over all the important PowerPoints and everything that I posted online up until this point. So we're in 7th period. So, remember the first week of school, we started out talking about lab safety, but there's not going to be any lab safety questions on the test, so I wouldn't really worry about that. In fact, I would start going over everything for the second week. So on the test, it's going to be very important that you guys know how to do metric conversions. So if I were you, I would go over this metric conversion worksheet here so that you guys understand how to read this table. Because remember, we went over this at the beginning of the school year, how to convert your units. So, for example, how if I give you a question on the test where I ask you to convert from kilometers to centimeters, you guys need to know how to do that. In order to go from kilo to centi, basically we need to move over 1, 2, 3, 4, 5 columns to the right. Okay, so what that tells us, we need to move our decimal place over 5 places to the right whenever you're converting from kilo to centi. So be sure you understand how to read this table. Because there will be a few questions involving converting your units on the test. And remember, there's a mnemonic device for how to remember the order of these columns. Kiss her dearly because divorce costs money. So if you remember that mnemonic device, you can remember the order of the table. Kilo, hecto, deca, your basic units, deci, centi, milli. Or of course, you can just use the table on the test because obviously since you guys are at home, you have access to your notes and you have access to the PowerPoint. Also, guys, please be sure you know how to do calculations involving scientific notation. So please be sure you know how to enter exponents. If you do not have a calculator at home, some sort of graphing calculator or scientific calculator, then what I would do, I would go to Google and use the calculator in Google. So at on Google.com, I will just type in calculator here in the search bar. And this calculator that comes up, this is the calculator that I would use. And so, for example, suppose you want to enter exponents in your calculator. Here's how you would do this. So, for instance, suppose you want to enter like 3 times 10 to the 9 or something like that. How would you enter that in your calculator? Well, you just put 3 times 10. If you guys see this X to the Y key here, you're going to click that and raise it to some power. And so that's how you enter exponents. Let's do another example. Let's do 4 times 10 to the negative 7. So do 4 times 10 and click this X to the Y key button here. So 4 times 10 to the negative 7 will look something like that. And so 4e negative 7 just means 4 times 10 to the negative 7. So always use this key here whenever you're entering exponents in your calculator. Okay, just something to keep in mind. What else do you guys need to know for the test? Also, please, everyone, go over the speed PowerPoint. Let me see, where is that? Where's that PowerPoint? Yeah, here it is. Go over the speed PowerPoint. Basically know all these terms in the PowerPoint. More importantly, I would know this equation here. Speed is equal to distance divided by time, which is also your equation for velocity, because mathematically speed and velocity mean the same thing, even though we know one includes direction and the other doesn't. You can see several problems on the test that look very similar to this, where you will have to use your speed equation. So please be sure you know how to deal with the speed equation, where speed is equal to distance over time. Or suppose you're given a problem like number 2, where it asks you to solve for distance, right? Because it says how far. In this case, you will just rearrange this equation at the top, where you will get distance is equal to speed multiplied by time. Okay. Or you could have a problem like number 3, where it asks you to solve for time itself, where it says how long did the object take to travel. So in this case, if you rearrange this equation to get t by itself, you would just be left with time is equal to distance divided by speed. Okay. So please be sure you know how to use all 3 forms of these equations depending on the problem that you're given. Also, I think I remember seeing one problem on the test where you had to convert units, where your time had to be in seconds, but it gave you your time. I can't remember if it gave you your time in hours or minutes, but and either way, just be sure you would have to convert to seconds to get your answer if your units require that your number be in seconds. So, and you guys should know how to convert from hours to seconds or from minutes to seconds. You can easily use Google for that to do those computations for you. So just something to keep in mind. Also, I would go over the acceleration PowerPoint as well. So there was an acceleration PowerPoint that I posted. I would go over the acceleration PowerPoint. And also, these acceleration practice problems are still available in Schoology for you all. Basically, using this equation, acceleration is equal to final velocity minus initial velocity divided by time. So I would go over some of these problems here, just to be sure you guys are good on using the acceleration equation. So I would go over that. Also, guys, please be sure that you understand the meaning of acceleration. Conceptually, what does a constant acceleration mean? And we talked about this a few weeks ago. I'm going to pull up this worksheet that we did in class, so you guys will get an idea of what I'm referring to. So if y'all remember doing something like this in class, if we look at number 1, it says a car starts from rest at 0 seconds and moves in the positive direction. It has a constant acceleration of 12 meters per second squared. Label the instantaneous velocities on the motion map below for the first 4 seconds. So what does it mean for an object to be traveling with a constant acceleration? What does that mean? So guys, it's important that you guys know that a constant acceleration basically means that the object increases its velocity for every second that it's traveling. In other words, it increases its velocity at a constant rate. So for example, if this object right here, this car, is moving, if it starts off from rest, we know at 0 seconds, its initial velocity is 0 meters per second, right? Because it starts from rest. But then how fast is it moving after the first second? Well, that's easy. It's moving at 12 meters per second. And we know that because we know its rate of acceleration. How fast is it moving after the second second? Moving at 24 meters per second. How fast is it moving here after the third second? It's moving at 36 meters per second, and so on. So I think you guys get the point. So what a constant acceleration just basically means that for every second that time passes by, our velocity increases by 12 meters per second. So a constant acceleration just basically means we are increasing our velocity over time in this particular problem. Let's look at one more example. Let's look at number 2. And you guys walk me through this. Okay. So number 2 says a car is initially moving at 45 meters per second at 0 seconds and has a constant acceleration of 10 meters per second squared. Label the instantaneous velocities on the motion map below for the first 6 seconds. So in other words, we're figuring out how fast is it moving at each specific moment in time. So the initial velocity of the car, we're told, is 45 meters per second. So that's how fast it's moving at time 0. So here is moving at 45 meters per second. Someone tell me how fast is the car moving here, given its rate of acceleration? Anyone? After the first second, how fast is it moving? Anyone?
55.
Yep. 55 meters per second. Exactly. Let's keep going. How fast is it moving after the second second? Yep, someone said 65 in the chat box. Yes, thank you, Jade. How fast is it moving here?
$75.
Yep, 75 meters per second. So you guys get the point. And of course, here we're moving at 85 meters per second. Okay. So just FYI, guys, anytime you know an object has a constant acceleration, know what that means. In this case, since the constant acceleration is 10 meters per second squared, that basically means that for every second that passes by, the car increases its velocity by 10 meters per second. That's what a constant acceleration means. Just something that you guys need to be aware of. Okay, constant acceleration just means, in this case right here, an increase in velocity at a constant rate for every second. Okay. Now, on the test tomorrow, it's going to be important that you guys know how to interpret graphs. Something that's pretty important. So on the test, we're going to mainly see position versus time graphs and velocity versus time graphs. And guys, if I give you 2 lines that looks like this on a position time graph, a line in red here and a line in blue. So these represents 2 functions. So someone tell me which function, the one in blue or the one in red, represents an object moving at a faster pace. Which one? The line in blue or the line in red? Yes, thank you, Anthony. Blue is moving faster. Exactly, blue is definitely moving faster. And you know blue is moving faster because it has the steeper it has a steeper slope. Exactly, the steeper the slope on a position versus time graph, the greater the velocity, because the slope on a position time graph is the object's velocity. So if I had to draw these exact same functions on a velocity versus time graph, that would look something like this. So assuming hypothetically, I take the slope of this line and I get 8 meters per second for my velocity, then my velocity time graph will look something like this. It has to be a straight horizontal line. Let me make that line straight as possible. So it's a straight horizontal line going through 8 meters per second. Okay. So, and of course, the red line will have to have a smaller value to its velocity because the slope is not as steep. So let's say this slope here would be at, I don't know, just throwing out a hypothetical number of 5 meters per second. Okay. And again, the straight horizontal line indicates a constant velocity. So in this case, this constant velocity here for the blue line is 8 meters per second. For the red line, it's at 5 meters per second. So remember, guys, on a position versus time graph, anytime you see straight sloping lines, so straight sloping lines with no curves, indicates an object that is moving at a constant velocity. So hence, that's why we drew it like this on our velocity versus time graph. The velocity stays constant with time. Okay. Let us look at some more examples. Does anyone in here remember what this right here represents on a position versus time graph? Hold on, let me make that a little thicker than that. Okay. What does that line mean on a position versus time graph?
It's slowing down.
Yep, it's slowing down. In what direction?
Positive.
No, not positive. Is that going downhill or uphill? That line. I mean, the curve. Is it going?
Down.
It's going downhill. So downhill. Remember, if your curve appears to be going downhill, that always indicates an object traveling in the negative direction. If the curve appears to be going uphill on a position versus time graph, that always indicates an object traveling in the positive direction. So this object is slowing down in the negative direction. Okay. And here's how you knew it was slowing down, because guys, look at the curve. Is the curve getting flatter with time or steeper with time? What do y'all think?
Flatter with time.
Yeah, it's getting flatter with time, right? It starts off steep, but then it gets flatter and flatter and flatter. So the curve flattens out. So anytime you see a curve on a position time graph that gets flatter with time, that always indicates an object slowing down. So since this curve appears to be going downhill and it's flattening out, that indicates an object slowing down in the negative direction. So if I had to draw this exact same scenario on a velocity versus time graph, that would look something like this. So I will have to draw my line on the negative half because we're moving in the negative direction, and it has to be going closer to 0 because it's slowing down. So that right there means an object slowing down in the negative direction. Okay. So that's what both these graphs are telling us. Guys, what if I gave you a curve that looks something like this on a position versus time graph? What does that mean? Let me draw that better than that. Yeah. What does this mean here, guys? What does that mean? Anyone? Well, so you guys notice we're going uphill, which means we're moving in the positive direction, and we're getting steeper with time. So that means we're speeding up. So if I have to draw this exact same scenario on the velocity time graph, I better draw my line on the top half, and it better be going further away from 0 because it's speeding up. And let me draw a better line than that. That's not a, for the velocity time graph, our lines have to be perfectly straight like this. So that's how it looks like on a velocity versus time graph. Let's do one more scenario. What if I gave you guys a position versus time graph that looks something like this? So we had a curved line like this. What does that mean? Someone tell me what type of motion is that depicting? So if you notice, I'm sorry?
Slowing down.
No, it's not slowing down. Actually, it's speeding up. Here's how you know that. Because notice the curve, it starts off flat, but then the curve gets steeper. So since it gets steeper with time, that means it's speeding up. To be specific, it's speeding up in the negative direction because we're going downhill. So here our position versus time graph is speeding up. Well, it represents an object speeding up in the negative direction. So that means on our velocity versus time graph, we need to represent it like this. We want to draw an object on the negative end, and it has to be going further away from 0. So like this. So both these situations represent an object speeding up in the negative direction. Okay. One more thing that I want to say before we end this call here. Whenever I give you guys position versus time graphs and velocity versus time graphs, and of course, I've already said this for the position versus time graph, but I'm going to repeat myself again because I want to reiterate this point. Anytime you have a position versus time graph, the slope of the line for a position versus time graph always indicates the object's velocity. And I'm gonna write that down because that's pretty important. Okay, the slope of the line for a position versus time graph always indicates the object's velocity. So I'm gonna write that down. Slope is equal to the object's velocity. Okay, that is always the case. The slope of the line on a position versus time graph indicates the object's velocity. But guys, let me ask you a question. What if I give you a velocity versus time graph and I ask you to take the slope of that line? What do you guys think the slope of this line represents? So the slope of this line on a velocity versus time graph, what physical quantity does that represent? I'm going to give y'all a hint. It starts with the A.
Accelerate.
Yes, ma'am. Slope represents acceleration on a velocity versus time graph. So just something that you guys need to keep in mind. On a position versus time graph, the slope of the line always represents the object's velocity. On a velocity versus time graph, the slope of the line always represents the object's acceleration. Okay, just something to keep in mind. Okay, so I am going to, as soon as 12 o'clock hits, or somewhere around 12, sometime around noon, I'm going to post a exit ticket for the week, and you guys should be able to get that done pretty quickly, and then you're going to use the remainder of your time to study for your test. I am going to post the test sometime between 7:30 and 8 o'clock tomorrow morning. Okay. You will have till midnight to get the test done. The test must be done by midnight because grades are due this weekend. It has to be done by midnight. No exceptions to that. So get that done because obviously it's a test grade and it also counts for your attendance. If there are no immediate questions for me, you guys are free to go.